Lag is killing me. Okay, over. Because if I set it, it takes little time to see the settings. Because of lag, I should see everything visible there. Top is not visible, I think. Okay, now okay, but still. Okay, I can write it that side, no problem. Okay, now it's okay, not worry. 1 minute, it to this side. Okay, I'll come up to here so that it will straighten. Side is okay, manageable. Further setting means it will become difficult. If I keep on setting like this, till I get the app, it is a problem only. 1 minute. Till the app comes, it is problem only. Now okay. Full visible now. Okay, 1 minute now. I'll come back. Okay, top portion is little problem. Okay, we'll bother about it. These things all. Now it's okay. Now you can see everything and voice is clear. You can see everything. Top not visible. It is visible fully. Who told? See, consider. It is visible. If I can see here, it is actually means visible only. If I can see here, it should be visible. Voice is fine. What is not visible? Top is visible. See, consider. Top is fine. Okay, this top I will not go. This top is slightly faint it is. No, it is little faint, rubbed out. Voice is okay and visible. Okay. I will start. Now, see. Yesterday I told about Rankine's formula, derived it. Now, validity, I proved it. Now we will consider example. See, you write here. Example. Red color better. Example. You write here. Example for correctly understanding applicability or correctly understanding the Rankine's formula. You write that way. Example for correctly understanding Rankine's formula. Write note. Okay. What you will do is consider a column of hollow circular section of outer diameter 150 mm and thickness 10 mm. Crushing stress and modulus of elasticity. Remember, I told you already, crushing stress and modulus of elasticity, they are property of the material. It has nothing to do with the length cross section. It is a material property. Or respectively, 330 is the crushing stress, 200 to the power 3 is E. Consider effective length equal to, I will give you list of effective length now. To correctly understand, I will tell different effective lengths. Okay, now make a note. Now what you require, see, first of all, doubt. What required? See, what you require is, see, find Euler's buckling load, comma, crushing load and what? Rankine's failure load. Failure load symbol is PF. I told you. You find for this one Euler's buckling load, then crushing load. Crushing load is independent of length, and Rankine's failure load, which combines these two. And make a note, and then discuss the importance and discuss the what? Result. Discuss the result. Okay, now make a note here. This I will give you. Make a note. Oh, this column, cross section and material same as our previous class. Yes or no? This column, cross section and material is same as previous class example, where once we took 16 meter, then you took 4 points of meter, then 0.4 meter, then I took 0.2 meter. Yes or no? Length I am changing. Is the column cross section and properties of material same as earlier previous case? Or yes, therefore we will not waste time. Cross sectional properties and material properties. First I will write cross sectional property, area, least I and R. Material property, you should write not this way. Crushing stress sigma, there is no place to write here. Right here. Crushing stress for material, sigma CR, modulus of elasticity E are respectively how much? 330 Newton per mm square. 330 Newton per mm square, and this is 200 10 to the power 3, little mix of color, Newton per mm square. Okay, now area all, you already know it. I will do one thing now. I will go to WhatsApp, and in the group I will see what is the areas here. See, it is there. Where in my WhatsApp it is there. 1 minute. I know where somewhere here. So many photos are there. Just a minute. I will, instead of asking you, I will write by my photo only. Somewhere here. Not here. This is C-tab class. Where is the area property? Somewhere down. 1 minute. If you can give okay. No, got it. See. Area is, I won't show the calculation why. Already over earlier. For this one area, 4398.230 mm square, third decimal. Moment of inertia is 10.831 10 to the power 6 millimeter power 4. These are the properties I am writing. Okay. And least radius of variation R minimum root of I by A is 49.624 millimeter. You know to calculate all this value, but why calculate? Refer last time question where same cross section considered, so get the properties. And this is also same as last time. Now, what you will do is, first write basic formula. What all you have to do? See, today's class is meant for understanding purpose. Application we will do. They told us to calculate Euler's buckling load. Make a note. When you find Euler's buckling load, you never bother whether it is applicable or not. Right here. When you find, you should write. When you find Euler's buckling load, never bother whether it is applicable or not. If the column is short, it will give nonsense result. Let it give. We want to know what it gives. See? And therefore, you never discuss applicability. Then Euler's buckling load PB equal to pi square EI by L effective square, or PB equal to pi square EA by lambda square. What we will do is, we will find using this formula. Why? Tell me why? Not this one. We will use this formula. Tell the reason. Use this formula. You tell it. Get out. You get out. Tell why this formula. Where lambda is slenderness ratio equal to L effective by R minimum. Okay. Tell why this formula. Reason. Why this formula instead of that other formula. Reason. 1 nimisha. I will write the answer here because I know the answer. 83.5 kilonewton when length is how much? 16 meter. And when length is 4.2 meter, 1212.0. And when length is 0.4 meter, it is 133,622.1. And Rankine's load is 1 nimisha. Where is the Rankine's load? I have not written. Here, lambda I will write later. Okay. And Rankine's load I will write here. 79 point. You don't see here. What I am writing you don't see. 660.5 to save the time. And this is 1435.8. Is lambda 322. You don't see here. This is all we have done earlier. 4.2 84.6364. ಇದಕ್ಕೆ 8.06. Don't see that one. We will calculate. Tell me reason. Why this formula both are same? Why not this formula? Tell me. Answer. I told earlier. YouTube. I left YouTube. Okay. Tell me why this formula both are same. Why you replace I by AR square. Tell why this formula. Why not that formula? Reason. Tell me. But why this both are same? Euler's buckling load. Why this formula? Why not this formula? I told the reason earlier. You are forgetting everything. See here. Why you want this formula and why not that formula? Power reason. Because this formula you are considering slenderness ratio. Here see. Numerator is fully constant. Yes or no? See here. Pi constant. E constant. A constant. Why? For the given cross section, area is fixed. E is material property. So, in this formula, see numerator I and L effect is there. Of course, I is constant, no doubt. But here, you will not get idea for slenderness ratio. In the columns, slenderness ratio is the most powerful term. Therefore, you tell Euler your original formula. I am not telling you get out. I am changing to this format. So use this one. Clear? Use this formula. Clear or not? This formula to be used. I will tell all principles today. See, every principle I will tell today. Use this formula. Okay. Now, further. Then, this is over. Further, I write here now. One Euler's formula over. Further. Then I will tabulate further. Crushing load. Or you can make one note here. This clearly shows that Euler's buckling load is inversely proportional to square of the slenderness ratio. Or as slenderness ratio increases, buckling load decreases. Buckling load decreases means column will buckle at lesser load. Good or bad? Column will buckle at a lesser load. Good or bad? Strength point of view. Good or bad? Column will buckle at a lesser load. Good or bad? If the lambda increases, column will buckle at a lesser load. Good or bad? Good or bad? Fast your answer. A column buckles very easily. Bad. Because strength. That means the strength of the column is inversely proportional to slenderness ratio. This all I told earlier. Okay, over. Now, this not now. This last, not now. This is last, not right now. Okay, further. Right here. Now, further. Crushing load. PCR. You write crushing load is the load at which the column will get crushed. That will happen only for short column. Crushing cannot take place for a long column. But here, when you find crushing load, sigma CR into A, you never bother whether column is long or short. If the column is short, it will give correct answer. If the column is very, very short. If the column is long, crushing load will come what? much more than buckling load. Before that, column will buckle. So, never bother about applicability. Simply find crushing load. When you do find buckling load, you never bother what? If the column is short, what to do? When you do crushing load, never bother if column is what? If column is what? Long or not. This I can do right now only. Why? See, this PB will depend on lambda. Lambda equal to L effective by R. Effective length is keep on changing. Therefore, this I can't apply. This I can do right now. 330 into area 4398.230. That comes in Newton, or you can tell crushing load. Tell the answer. Crushing load for the column PCR equal to, irrespective of length, no lambda, nothing. No lambda, nothing. Nothing. Answer given kilonewton. This also you know it. Answer. What is the answer? Crushing load 1451.42. Okay. 1451.42. Is it the same answer for all these effective lengths? Tell me. Is it the same answer for all these effective length? Tell me yes or no. But it may not be the real answer. It may not be applicable. But numerically, is it same for all effective length? Tell me yes or no. Yes. Okay. Now do one thing. Now go for what? Rankine's failure load. Rankine's failure load. See, we got formula for Rankine's failure load. You write. Right now you write a note here. That is PF. You write here. Yesterday's class we derived expression for Rankine's failure load, sigma CR into A by 1 plus alpha into lambda square, where alpha is Rankine constant equal to FCR sigma CR by pi square E. You write. But we are now discussing behavior. Therefore, do not use the formula. You use the original expression proposed by Rankine. So, the original expression is 1 by PF. PF is what? Rankine's failure load. Rankine's failure load equal to 1 by PCR plus 1 by PB. You can interchange. 1 by PCR plus 1 by PB is the original formula. Use this. This only after simplification gave you that formula. When you do numericals later, you do that formula. But for today's logical discussion, use this formula. Okay. Now, 1 by PCR is fixed. PCR is known. But PB will keep on changing based on, see, this will keep on changing. This will change based on lambda. Therefore, this also will keep on changing. Yes or no? This will keep on changing based on lambda. So, this also will keep on changing. Tell yes or no. If you use different effective length, the buckling load will change. Therefore, Rankine's load also will change. Yes, actually, you are not told yes. Actually, it is understood. If Rankine's load is not changing, then Rankine's formula is nonsense. Rankine told my formula is accountable for, is applicable for all type of column means. So therefore, as the column type changes, long, short, intermediate, your value has to change. Okay, start. Now, correctly start. I want some extreme conditions. See here. I will put a list later here. But let me see how much space available in the board. I should see that one. Let me put a light line here up to where I can write, so that almost up to here this person is not going. Go that side. He is still not going. Now he went. Illi. Hey, what is this? Here. He is not allowing. Here. Here, oh, space not there. Space not there. Or I have to enlarge it. Illi. Oh, yes, he came. Okay, 1 minute here. Okay, this line. Okay, that line tally is okay for me. Illa. No. This line. This person is not drawing the line. ಜಾಸ್ತಿ ಆಯಿತು. ಅಯ್ಯೋ, ಒಂದೇ ನಿಮಿಷ. There are 3 lines here. I can see only 2 lines. What he is doing? Draw one more line. Finally, okay, manageable. Start with. Okay, now I am scolding myself only. Okay, now what I will do is I want to save the space. So I will do one thing now. I will start calculating here and then I will prepare a chart there, slow chart there. As I will get the answer for discussion. See, I told you, complete concept will be told for you, not simply a problem. So this I will remove, not required. This I will remove, effective length I will give you. And then section property also I will remove. Even user also I will remove. I don't require area is already known for you. Pi square EA area area equal to save the time 4398.230. Okay, lambda I'll tell. So area also over, R minimum also I'll write here to save time is 49.624. Okay, now start. Enough. Start. I will write correctly understanding. See now. Case 1, red color. Case 1. L effective equal to, I will take a huge effective length, 30 meter. Someone will tell, 30 meter. What is this one? Imagination. Imagine. I want a case where, tell me, column should fail by what? Tell me. I want a case where column will really fail by which one? Column will really fail by what? I want a case where column really fails by. Fails by how? Fails by. I want a case when column really fails by. Any problem there? Is it visible? Is it not visible? One minute. I will slightly reduce it because it is not visible. Fully not visible, I think. Okay. Little short I will make because technical point is more important. We can't sacrifice decoration for that purpose. Ayyo. One fine slot, it should be okay. Okay, now, just a minute. That inclined portion is irritating me. One side lesser, one side higher. Whatever I try, the tripod is not adjusting properly. I think that this tripod, costly tripod, I don't know why they are not given one setting there. Little more. Is setting a time I tell her. Just a minute. Now I can operate little more length. Okay. I can operate little more length now. Crushing stress. Further. Oh. It is taking hours together to move. Even crushing load also I can remove. Okay. Now, okay. Manage today. For discussion purpose, somehow manage. Nice. Okay. Discussion person. I touched the tripod. See, sometime when I came this side, I touched the tripod. Okay, I think. Okay, now see, even I do not require crushing load also now. I do not require. Lambda is there. Okay. ಆಯ್ತು ಸಾಕು ಬಿಡಿ. Tell correctly effective length. Or I will do one thing now. Since you already know how to calculate, I will put some other way. So correctly understand, I will put case number. Case number. Case number. Red only. Case number. What is L effective in meter? Case number L effective in meter. Okay. Next column will be, see, when you get L effective in meter, immediately you get lambda. Lambda equal to L effective by R minimum. R minimum. Okay. Remember, L effective in meter, lambda has no unit. It is a ratio. It is a ratio. No, that much I should not tell. Lambda has no unit. Okay, then I will go further. Next I will go for what? Next I will go for PB. No, lambda over PB. That is Euler's buckling load. Euler's buckling load. In kilonewton, I want answer. Or I will do one thing. Length I will put unit here. See, I will put meter here. PB, Euler's buckling load. And remember, for all the cases, one constant, what tell me? For all the cases, what is constant? PCR. That is crushing load. Crushing load is fixed. How much answer? How much you told just now? Oh, I forgot it. I removed it now. Anybody can tell the answer? It is there somewhere. 1451.42 kilonewton. Common. Clear? It is constant for all the cases. Okay. Then I want, this is PCR. What is Rankine's failure load? Rankine's failure load, that is PF. PF. Rankine failure load, I will put in kilonewton. Okay, then further I want something else now. See, Rankine's failure load over, how you got to get it? Get by this formula. What? 1 by PF equal to 1 by PCR plus 1 by PB. Get by this formula. Okay, then what I want is, what? Lambda. Now I will write somewhere here. See, we know, leave it now. Then we will go for discussion. This is for discussion. 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 I will write here. Now, make a note. Now only make a note. This I will remove. See, Rankine's failure load formula. Shall I remove it? 1 by PF equal to 1 by PB or 1 by PCR. 1 by PCR plus 1 by PB. Okay, that also over. Jaga bekili. Wait for a while. Case number I two. Okay, then discussion here. Okay. This is the formula for failure load. Okay, now, then somewhere here I will make a note. See, case 1, case 2, case 1 I will go for 30 meter. Case 2 I will go for same as our class example 16 meter. This is already solved in earlier class. Case 3 I will go for 4.2 meter. This also already solved in the class. Case 4 I will go for very short 0.4 meter. This also already solved. Case 5 very small, I will go to only 0.1 meter, just 10 centimeter. Very small. Right. Meter, be careful. Okay. Lambda. See, I will fill up the lambda values now. See now, what I am doing. Discussion later. Calculation, you already know it. Why should I calculate? 30, see, when L is in meter and your R is in millimeter, how much? 49.625, length should be converted to millimeter. 30,000 divided by 49.624. Your lambda is 604, very huge, 0.546. When the L effective is 16 meter, it is 322, this already I got last time, 322.422. When lambda effective length is 4.2 meter, we already got 84.6364. 6364. I want one thing now. I want one more length here, not 4.2 meter, one more length, 3.2 meter. One more I want, 3.2 meter. Okay. If it is 3.2 meter, it is 245. Something wrong. I can make out. I am not that much fool. 64.485. 64.485. Then next I will take how much? 0.4 meter. Small red color. Okay, red is actually not required. Still to understand. 0.4 meter. Now answer is already known. 0.4 ge 84 point, 0.4 ge 8.06. 8.06. Then I will take sixth one, very small, 0.1 meter. Saku. 0.1 meter. 0.1 meter ge 100 divided by 49.624. 2.015. Oh, red answer blue early. 2.015. These are the values. Now, I want buckling load in kilonewton. See now, what I will do is, if I substitute here, pi square into E, 210 to the power 3 into area. Where is area? Area is 4398.230. That is the buckling load, pi square EA. I will store in memory. Now, memory recall memory divided by 604.546 square. It comes to 23, something wrong I think. What is the answer there? Correct. It is 23.754 kilonewton. Remember, when you calculate, you are getting Newton, convert to kilonewton. All is clear. When you calculate, you are first getting Newton, convert to kilonewton. All clear or not? Don't get confused about unit. All clear? When you calculate, first Newton will come. Because by substitution in newtons and millimeter, you have to convert to kilonewton. Clear or not? No, clear or not? You are no answering. When you substitute, you would clear. Okay, now second one answer. It is recall memory divided by 322.422 square. Actually, waste of time. Answer is there last time done. 83.513 kilonewton. When the effect length is 4.2 meter, I know the answer. Why should I calculate? It is 1336. Correct idea? Doubt. 3.2 meter. 320. Shift recall A divided by lambda is 84. Adaiko. 16 meter is to 85 point something, correct. 4.2 meter 83.513 is for 16. And 4.2 get to 4.2 84 point. What is this one? Something went wrong. 1 minute now. Here it is wrong, I think. 1 minute here. L effective. What is L effective? 4200 divided by 49.624. It is 84 point something. Shift recall A divided by 84.6344 square. Is 1212. ನೋಡಿ ಅಲ್ಲೇ ಗೊತ್ತಾಗ್ತಾ ಇದೆ. ಇದು 12.2 kilonewton. ಅಲ್ಲೂ ಇದೆ ಅಲ್ಲಿ ಆನ್ಸರ್. ಅಲ್ಲಿದೆ ನೋಡಿ, ಅಲ್ಲಿ ಕಾಣ್ತಾ ಇದೆ 2 kilonewton. ನೆಕ್ಸ್ಟ್ ಒನ್ 64.485 ಗೆ ಶಿಫ್ಟ್ ರಿಕಾಲ್ ಎ ಡಿವೈಡ್ ಬೈ 64.485 ಸ್ಕ್ವೇರ್. ಇಟ್ ಈಸ್ 2087.81 kilonewton. When it is 0.4 meter, abnormal value, it is shift store A divided by 8.06 square. It is 1,33,620.4 kilonewton. Remember this value? It is still there. Okay. Then when it is 0.1 meter, shift store A divided by 2.015 square. Oh yo, it is 21 lakhs 38,000, almost one huge building. 38,245.5. If this much load can take for a big building, 10-15 story building, this one column is sufficient. Okay, now for all this one, buckling load is same. Now here, see, here what you do is, I want PF here, see, 1 by PF equal to 1 by, first one I am telling first one. 1 by PF equal to 1 by PCR, 1451.42 plus 1 by, it is 1 by 23.754. Therefore, for the first question, I'll do one thing. Okay, I want to one thing. I'll put here. See, 1 by PF equal to 1 by PCR plus 1 by PV. Jaga illa. First one answer is only for first one. 1 by PF equal to 1 by crushing load, 1451.42 plus 1 by 23.754. So for the first question, jaga illa illi adjust ಮಾಡಬೇಕು. Okay. For the first one. For the first one, your failure load, Rankine's failure load is 1451.42 reciprocal plus 23.754 reciprocal equal to reciprocal. Once again, answer equal to 23.371 kilonewton is the answer for first one. Clear? Rankine's failure load for first column is 23.371. Clear how I got? No, clear how I got? Use the original formula. Clear or not? That's how I got Rankine's load for first case. Yes or no? You are not answering first of all. See, no reply, nothing. It looks I am talking to myself only. Clear? Okay, now same way for second column, third column, fourth column, fifth column and sixth column, get the value in kilonewton. Can you get it? Type in correct order 5 values. 5 values, type in correct order. I'll take a small break. You calculate correctly, no mistake. Correctly calculate. See everywhere. 1 by PF equal to this reciprocal plus this reciprocal, then reciprocal. This reciprocal plus this reciprocal, whatever you get, again reciprocal. Kilonewton, no Newton now, because why? Result in kilonewton. Type these 5 values. I will take some 4-5 minutes break. Agreed? Type the 5 values. Agreed or not? I will take 4-5 minutes break. Type the 5 values in order. Don't make mistake, because discussion is the most important. Practical knowledge, in the discussion, after finishing this one, what I discuss here will give you complete idea about column strength in buildings or long column, short column, intermediate column, RCC or steel. Good idea will come. Okay, start. I'll take 5 minutes break. Why this much time? Just to find reciprocals and reciprocal, this much time. You are taking the time beyond the limit. This much time to find reciprocals. But what you are doing? Still not over. Means you are not seriously calculating. This much time still reciprocal, sum of the reciprocal and reciprocal. This also you want me to do? See, this is called what I can tell. No response. Then feeling comes. Why should I explain all these things? If still answer is not there, after all, some reciprocal addition, and one more reciprocal. Or you can write formula and ask it to calculate. PCR is constant. You substitute PB, you get PF. I don't know why you are taking this much time. This much time is not justified. This way, if you give the answer, difficult to take the class. Very difficult to take the class. If this much time is taken to give some 4-5 answers, that too simple mathematics, no complication, nothing, no time to explain. Then, because see, today I have taken non-stop class in the college from 2 o'clock up to 4:35. Then I came here, feeling too tired. You are making me more tired now. I thought it will come within half minute. Before I reach inside, I thought answer will come. Still no answer. How much time I have to wait? That's why sometimes I feel recorded class is better. Where? Where I am not seeing any answer. Yellide. Where I am not seeing any answer. ಈಗ ಬರ್ತಾ ಇದೆ ಆನ್ಸರ್ ನೋಡಿ. 23.372 ಅದು ಆಲ್ರೆಡಿ ಆಯ್ತಲ್ಲ, ಅದು ಆಲ್ರೆಡಿ ಆಯಿತು. ನೆಕ್ಸ್ಟ್ ಒನ್ 78.969 ಆರ್ ಐ ಕ್ಯಾನ್ ಟೇಕ್ 79. ಐ ಕ್ಯಾನ್ ಟೇಕ್ ಚಿಲ್ಲರೆ ಬೇಡ. 79 kilonewton. Then 660 is already there. It is new one. 660 already there. 660 already there. 660.5 kilonewton. Next one is 856.2 kilonewton. 1435.8 kilonewton. 1451.42 kilonewton. Okay, these are the answer. Now, see now. See, correctly answer. I will discuss something. Now do one thing. Now write some statement. Now you should write somewhere outside. You tag it. You tell, after all this are over, at the time of discussion, consider star. Consider star. What is star? Star is here. Consider star. Right. Star is, it is here. Star. We know that Euler's formula is applicable only if lambda is either equal or more than root pi square e by sigma cr e equal to 210 the power 3. Sigma cr is 330. Therefore, the star will be what? The star will be Euler's formula. Euler's formula is applicable for this column, not all the columns. Column only if I see the space there. If space is no problem, I write there. Only if, oh, not visible, not visible. Okay. I'll make it visible. I should fast do as early as possible. I should introduce an app. Hey, an app I should get. I don't know how to put that app. ಏನು ಆಟ ಆಡ್ತಾ ಇದೆ ಇದು? Okay, I'll go little this side. Little small statement. Board is inclined. I don't like this appearance. Fully inclined board. Looks horrible. These people who gave this tripod, it's a very costly tripod. They told all setting possible. Here, everything is possible except the. Okay. Now, again slant. You feel like throwing it outside. This slant thing I don't like. It looks very odd. Someone will tell, what is this? Okay, because the discussion is very critical. I should do something for this one. Because of the lag here, if I do correction to check visible or not, I had to wait for some time. See, it takes half an hour to show me case 1, case 2. Till now. Yes, now came. Okay, now came. I should carefully walk, should not touch. I will do something tomorrow for setting up the tripod. Earlier it was, that problem was not there. Okay, now write a note. See, visible. See, I'll write once again. It's big letters. 1 minute. These things actually will spoil the. Actually, such things, what happens is, the seriousness is gone. This arda gante nodakaike. Go there. Lag a problem. It is showing live and still not showing the end. Okay, right here. Euler's formula, red color I am writing. Euler's formula is applicable only if slenderness ratio lambda is more than or equal to how much? This number. How much? Tell this number. Tell me this number. Yesterday we got it. 77 point. What was that number? Tell me. That number. Yesterday we got it. That number. 77 point. Not if long. Long means how much long? The number. That number only will tell you long or short. We got some number yesterday. What number? 77 point. See? If you tell only if column is long means how you can do calculation? Some number required. Based on that, we got a number 77.34. So only if lambda is more than 77.34 for this column. Why? For this column, because for given sigma r and e, it will change from material to material. Clear? It will change from material to material. Clear or not? Material to material it will change. This is for steel. Clear? Little fast. Again, not replying. Clear? Okay. Now, right here. See, some statement that does not mean that you should write. Euler's formula will give correct result if lambda is more than 77.34. No. Euler's that does not, it is applicable, no doubt. At least common sense point of view, applicable. Why? This is the case when your buckling load is what? Less than or equal to crushing load. Your buckling will take place first, then crushing. But that does not mean that this, if the lambda is more than 77.34, Euler's formula is applicable. It will not give correct answer. Okay, but it is not nonsense. Okay, now, but remember, but note, Euler's formula does not consider what? Does not consider which one? P by what? Sufficient. Does not consider P by. Does not consider P by. You know the answer. Does not consider P by. That is direct compression. P by. Does not consider P by A. That is what? It does not consider the effect of axial stress due to load. But tell me, frankly, it is to be considered or not? See, whatever happens, even if it buckles, because of the axial force, some stress will come. That will add up actually. That will add up. So, actually it is to be considered or not considered. Technically, effect of axial force must be considered. So, but effect of axial force need not be considered if the column is very what? Tell me. Effect of, I told you, 2 lakh rupees spent, 500 rupees railway fare. I told you, 2 lakh rupees spent, 500 rupees railway fare. Yes, you can ignore. So that effect of axial force need not be considered if column is very long. Now, right. Rankine's formula considers what? Considers both what? Direct compression and buckling effect. Tell yes or no? And buckling effect. Rankine's formula considers both direct compression and buckling effect. Correct? Tell me yes or no? Rankine's formula considers both direct compression and buckling effect. Tell yes or no? Yes. Therefore, actual failure load will be slightly lesser or more. Suppose a column is buckles. Buckling column is really long. Even then, actual failure will take place little earlier or later. Tell me. Actual failure will take place little earlier or later. Little earlier than buckling load or later. Little earlier. But remember, now do one thing. See, right here. Example number 1. When effective length is 30 meter, lambda is 604.546. You should write everything here. Everything you have to write. Example, you should write. Example 1. Effective length 30 meter and slenderness ratio is 604.546. 604.546. If you know steel structures all, is it abnormally high lambda or less lambda? People will run away from the building. See this pipe for 30 meter effective length. Is it small, that is small slenderness ratio or abnormally high? Tell me. It is abnormally high. Therefore, this is 100% is a long column. So, here, Euler's buckling load, we got 23.754 kilonewton and Rankine's load, we got 23.8 372 kilonewton. Oh, both are identical. But still, accounting for a axial force of 23.754 kilonewton, little axial stress will come. So Rankine told, apply little lesser load. Justified extreme long case, Rankine's formula is fully justified. Yes or no? Rankine's formula fully justified. Tell me yes or no. Rankine's formula fully justified. You tell yes or no. Fully justified. Yes. Now, come to example number 2. I write everything here. Example number 2. Red bada. Effective length is 16 meter. Lambda is 322.422. This also is quite long, but not as long as last time. Now, Euler's buckling load came at 83.513 kilonewton. Tell me, this here compression force is not very small. Therefore, Rankine told correct, but failure load will be slightly lesser. How much? 79 kilonewton. Or even now you can tell this column is long. The difference is not much. Yes or no? Difference is not much. But compared to last time, difference increased. Correct? Compared to last time, difference increased. Okay, now come to next one. 4.2 meter. This is very important. Case number 3 is 4.2 meter. Your lambda came at 6664 ಅದು 6664 ಇರಬೇಕು, ಕಾಣ್ತಾರೆ ಇಲ್ಲ. 84.63563. ಅಯ್ಯೋ ಸರಿಯಾಗಿ ನಂಬರೇ ಅಳಿಸ್ಬಿಟ್ರೆ ಹಿಂಗೆ ಆಗೋದು. ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ ಬಿಡಿ. ಎಷ್ಟದು? 4200 divided by what is the R value? I forgot the R value only. Anybody can tell what is the R value? 84.6364. It is there. 6364. Now remember, this column, is it abnormally long column or a intermediate column? It is not short. Is it abnormally long or intermediate? Tell me. Answer. Is it abnormally long or intermediate? Is it abnormally wrong column or intermediate? Intermediate column. See, this lambda is more than your conditional value of 77.34. So Euler's formula can be applied, but it won't give. Euler told column will buckle at what load? 1212.2 kilonewton. But now, if this buckling load is applied, it is a predominant load. There will be compression. So, strength will reduce or increase. Tell me. Because of the direct compression, strength will reduce or increase. Tell me. Because of direct compression, intermediate column, intermediate column, buckling load came more. Strength will reduce. So, Rankine told, no. This is exaggeration. 1212 is buckling load. No, see, crushing load is 1451.42. It is not very far off. It is a via media case. So he told failure take place at 660.5 kilonewton. 660.5 kilonewton. Now, it gets 660.5 kilonewton. Now do one thing. Now to understand further, find Rankine's formula load, Rankine's failure load by the real formula. That is what? Derived formula. That is sigma CR into A by 1 plus alpha into lambda square. Yesterday I asked you here 1 by 1 plus alpha into lambda square is what? Yes or no? I told you What is R? I can do one thing. This formula I can write sigma CR into 1 by 1 plus alpha lambda square. I told you what is the name for this one? Yes or no? I asked you yesterday. What is the name for that one? Okay, 1 minute. Substitute now. Substitute. Equal. Now you require lambda. Lambda you require alpha. Alpha equal to what? Pi square E by sigma CR. Tell the answer. Alpha. Pi square into 210 to the power 3 by sigma CR is 330. Tell the value of alpha. Tell the value of alpha. This we have not done earlier because why? Earlier direct formula. Now for some reason I want to apply Rankine's formula in the formula version. Alpha. Point. Fast. That is Rankine's constant. Point. Pi square. Vittayitu. Alpha equal to what? What is the formula? Pi square E by sigma CR is something. It is sigma CR by pi square E. Where you are? 330 divided by pi square divided by 200 10 to the power 3. Alpha equal to 330 divided by pi square divided by 200 10 to the power 3. Is it 0.016,718? Correct? 0.0016718. Correct? Correct or not? 0.0016718. Little fast. Time is not there. 0.0016718. Is it correct? ಇಷ್ಟೆಲ್ಲ ಒದ್ದಾಟನ. Correct. Okay. Therefore, if I substitute sigma CR into A equal to sigma CR is 330, area is 4000. Abba, who will remember this answer solve? Area, ಎಷ್ಟದ area ಅದು? ಬಾ number I should write somewhere. Otherwise, same problem. Searching. What is the area? Search the word comment. 4398.23. 4398.23. Remember, into 1 by 1 plus 0.0016718. What? Into 1 plus alpha into lambda square. Our lambda came 84 point. I'll remove this one now. 84.6364 square. Or now tell me, what is the meaning of this one? Tell me, what is sigma CR into A? Tell me, what is sigma CR into A? Tell me, what is sigma CR into A? No, what is it is the crushing load. This is PCR or equal. Tell the answer. This answer, why you calculate? You know it. But remember, answer comes in Newton, convert to kilonewton. It comes to 14, convert to kilonewton. 1451.42 into, tell this number, that number. So this is the crushing load. Into a number. Tell me that number. ಆಗೋಯ್ತು. ಅದು ಕೊಟ್ಟರೆ ಡಿಸ್ಕಷನ್ ಆಗೋಯ್ತು. Then not much. Other two are very simple because short column. That number, point, ಆ ನಂಬರ್ ಬೇಕು ನನಗೆ. 1 by 1 plus alpha into lambda square. That number, it comes to point. ನನ್ನ ಪ್ರಕಾರ ಅರ್ಧ ಬರ್ಬೋದು. ಎಷ್ಟು? 0.5556 ಆ ರೇಂಜಲ್ಲಿ ಬರುತ್ತೆ. 0.55 ಆರ್ 56 ಆ ರೇಂಜಲ್ಲಿ ಬರ್ಬೋದು. ಯು ಆರ್ ವೇಸ್ಟಿಂಗ್ ಲಾಟ್ ಆಫ್ ಟೈಮ್. ಐ ಟೋಲ್ಡ್ 1 plus 0.01618 into 84.6364 square reciprocal 0.5556. 4 5 4 5 ఇది 4 5 ఓకే కరెక్ట్ 0.455 505 0.455 455 505 or tell the answer now, multiply to this number, tell the Rankine's load in kilonewton, you should get the same answer. Etto same answer should come. Ettu barth nodi, multiply by this number and tell me Rankine's load, same answer has to come. 660.5 correct, 660.5. okay, now I will tell the real meaning. When the effective length is 4.2 meter, clear now, see what I am writing. When effective length is 4.2 meter, your slenderness ratio is 84.6364. So it is more than Euler's number. So Euler's formula is not nonsense, but it is wrong because it is the intermediate column. Here buckling effect is there. Also direct compression is there. You cannot ignore direct compression. Here P by A plus or minus M by Z, clear? Here P by, there in when pure buckling it is only M by Z. Pure short only P by A. Here P by A plus or minus M by Z, correct? Therefore Rankine told, instead of 1451.42 kilonewton, the real failure load is 660.5. He reduced by what percent? Tell me. The crushing load is reduced by what percent? Reduced by what percent? Reduced by what percent? Reduced by what percent? The crushing load, it is not short column. Reduced by what percent? What percent? Reduced by what percent? 50, reduced by 54. Ayyo, 45 only. How 54? Reduced by 45.5505%. Or he Rankine told, even though crushing load is 1451.2, buckling is there, you take strength as what? How much? Around what? 45 point. Reduced by correct. Reduced by what? When you tell reduced by correct answer. Sorry. Sridharmurthy is correct. Reduced by 54.5% or only 45.5%, strength remaining gone because of the intermediate. Axial load also is there, bending also is there. Clear now? Or tell me, if the column is very, very short, tell this number. If the column is very, 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 very short, tell this number. Very, 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 very short, tell this number. Tell this number. Then there is no reduction. Why? Column is very, very, very short means no reduction. Therefore 1 by 1 plus alpha lambda square is what? Is the reduction factor. Reduction factor by Rankine. By Rankine for crushing load. For crushing load. Now start reverse. If the column is very, 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 very short, no reduction. Whatever crushing load you get is the failure load. See here. 1451.42, 1451.42. See, 1451.42, 1435.8, maybe 2% or very small percent. As you go up, as the length increases, length effect will come, bending will come, so strength will keep on what? As the length increases, reduction factor will decrease, so strength will keep on. As length increases, reduction factor will decrease, strength will reduce. So this is reduction factor. Clear? It is so this term is called reduction factor for what? Due to slenderness ratio. See, in the steel, remember reduction factor? Tell correctly. 1 by something in steel structures. When you do column, do you remember reduction factor there in steel? Stress reduction factor. Yes, you forgot it. I still remember. So remember now what? 1 by this number is, see, this number is reduction factor. If reduction factor is almost 1, if column is what? It started raining now. Reduction factor is 1, if column is very, very, very. Reduction factor is 1, no reduction. Reduction factor 1 means no reduction. Column is very, very short. As the column becomes more and more longer, reduction factor will reduce. Correct? Here, see, if the column is very long, reduction factor can come to 10%. Even though crushing at 100, you apply only 10. Very weak column. Is the concept fully clear? Yes, okay. Started raining now. I will continue tomorrow. Tomorrow I will continue. Thank you. Started raining.